Is it recording? Okay, it is recording. So. All right, so I'm gonna pop up the notes with you guys. So today you guys have two. For today's lesson, you guys have a little worksheet type of thing that you're gonna follow along with. And again, if you check out your weekly schedule for that, on there today is just called Formation of Our Solar System Worksheet. So you're just gonna turn in that worksheet and then kind of take some simple notes with that. Also, before we get started too far, hopefully we'll have some time at the end. I talked to some of you guys individually about taking that Star Cycle quiz. Again, that Star Cycle quiz is going to close today at midnight. If you want to retake it for any reason, you can retake it also until midnight tonight. I am not going to reopen it. So again, I'm giving you guys 5 days to take that quiz. And I told you to do it on your own time. And so we need to make sure we're taking that quiz. Okay, that's going to be a really bad zero. That's going to hurt the grade a lot if we don't fix that. Okay, so it's definitely something we want to try to fix. All right, so formation of our solar system today. Let me share my screen. Okay. So today the notes are going to be pretty straightforward. Again, as always, I encourage you guys to have paper and pencil. We are going to have hopefully a little bit of time at the end of class to kind of help work together. But we are basically going to finish all of these slides today. And we're basically going to hit the topic. So this is going to cover us for the entire week. And then on Friday, talk a little bit about planet Earth itself. So again, as always, if you guys have questions or anything, just put them in the chat box. I'll check on them periodically every few minutes or so. So formation of our solar system. Remember we talked about stars and that our sun, our star, is a third generation star. We talked about how we know that is based on the elements that are in our solar system, especially in on planet Earth, but also looking at other planets, Mars, Mercury, Venus, the asteroids, comet, all those type of things. Looking at the elements that are in our solar system, we know that our star cannot be a first generation star because we have planets and stuff. Anyways, remember, first generation star would just be hydrogen and helium, and there wouldn't be anything else. There wouldn't be any other, bigger substances. So that first generation star had to make elements to make the solar system or other things. And when you think that it's enough, it's at least a third generation. And again, we don't know exactly, but it has to have been at least 3 stars have come before it. So I got people coming in here. Right, so our star, or our solar system. So the first object so our solar system is a remnant of a past supernova or a past planetary nebula. Probably a supernova because of the larger elements that are in our solar system. Our solar system naturally has up to 92 protons put together, which is uranium. That uranium is really large atom. It's only going to be formed in the process of supernovaing when that large star just compresses, and that put more and more and more protons together. And so again, based on the elements that we have, pretty certain that it must have been a previous supernova. Sorry, my dogs are barking again. All right. Anyway, so well, I'll just stick here. That way I can see if you guys have any questions or anything as well. All right. So the first object in our solar system were a result of a long ago supernova. We're talking again third generation. These stars are lasting for anywhere between 10 to 20. Anywhere between 1 to 10 billion years old. And so again, our sun being a third generation star. I think the universe is about almost 14 billion years. That those generation stars are going to be a little bit. The first generation stars weren't going to be that old when they ended up having the supernovas. Okay. All right. So from there. All right. So from there, so the past star made all the elements that are necessary for our current solar system to have our sun, our star, planet, moon, asteroids, comets, all that good stuff. Gravity brought all that material together from that planetary nebula, that area, the cloudy dust of elements. Gravity brought all that stuff together and to form our basic solar system. So the first bodies that were in our solar system due to gravity are called protobodies. And so we have a proto-star, proto-planet, proto-comet, proto-asteroid, whatever it is. And so the word proto basically means the start or the first or the baby type of that planet or that body, whatever it is. Okay. And so the early universe basically started off, again, because of gravity. So you see this picture here, we have this nebula, the planetary nebula. It's just a big cloudy dust orb. Okay, and it's a large spinning dust, cloud dust. It is flattened due to the rotational movement due to gravity. Okay, and in the center of that dusty cloud is where gravity is going to gather the most, because it's the center of gravity. Just like you have a center of gravity, the planet or the nebula cloud also has a center of gravity. So gravity brings the most amount of material to the center of this, and again, the object that's going to have the most amount of mass is going to be turned into a star. And again, the only thing that separates a star from a gas planet is having enough mass to ignite. Sorry, dog again. The only thing that's different between a star and a gas planet is having enough mass to ignite the gases within that body to undergo nuclear reaction. If there was enough gas and gravity worked out okay, Jupiter and Saturn could have also possibly turned into a star as well. Matter of fact, most solar systems do have more than one star. They're called binary solar systems, and that's just because there's enough material for multiple stars to form. Okay, and so in the early universe, approximately 4 billion years ago, okay, 4.5 billion years ago, in the center, gravity brought all the gases together to form a baby star, or what we'll call a protostar, and that will eventually become our sun. You can see in the picture that there are other things forming as well, which is going to go into the next slide right here. Okay. So in the early universe, we also have the formation of planets, and so you can see that this cloudy dust area, these dust and material going around in circles around the protostar, and again, as the material move around and round and round and round and round, they are going to collide and hit and run into each other, and again, gravity is going to bring that material together. So the planets in our solar system were formed from the same cloud that the sun was formed. And so pretty much our entire solar system is relatively the same age. Now, again, we're talking plus or minus millions of years. But remember, in a term, when you're talking about billions of years, millions of years isn't really that big of a deal. But the whole entire solar system was relatively formed at the same-ish time. Okay, so again, this disk of material called a planetary nebula, that is the nursery for planet. Again, this disk is mostly comprised of hydrogen and helium from the previous star, but it also has elements that previous star made and fused together. Okay, and that depends on the life of that star. What elements did it make? Okay, the previous generation for ours made quite a few elements. Okay, that. Again, kind of how we know what's going on there. So after we have our, after we go from there, we actually have basically a very smallest little pieces of materials, and we call them planetesimals. Planetesimals are basically the first bits of material that start forming together. So again, the nebula has a certain amount of angular momentum. It is spinning around the center of gravity, and it flattens when it does that. If you've ever, if you ever been like on a swing or at a park and anything that spins around, you notice that even if you make a mistake on the spin, it eventually corrects itself. And that's called angular momentum. Is that when something is moving around a pivot point or around a center point, that even if you go off course, it will eventually recorrect itself and kind of fix itself against that pattern. Okay? And so particles of that spinning disk begin to clump together due to gravity, and that attracts them to each other. And those small bodies are called planetesimals. So planetesimals are like the very first bits of matter coming together, besides hydrogen and helium, but starting to form something. Okay. Then over time, you get more and more and more stuff, and you start getting things that are called protoplanets. And again, a protoplanet is obviously something that's going to be large. It's not a moon, it's not an asteroid, it's not a comet. It's a large body that is starting to come together. So you see this picture here, we got proto-Earth that's kind of hanging out here, proto-Mars. We got the thing called Vesta, which we'll kind of talk about a little bit later. Okay, so there are lots of different, rocky bodies that are out here. Okay, and again, when you get to a protoplanet, this is the first step of the planet itself, but it is, becoming very, it's starting to become together. Okay? Obviously, as you can imagine, this is not a very ideal place to live on the baby planet, because again, you're getting a loss of matter is still being added and clumped to it, and the planets are just getting bigger and bigger and bigger and bigger and bigger over the millions of years that they're doing this. Okay, and so the very first stages of the planets is kind of a rough spot to be in, and we'll talk a lot more about that in the coming days when we talk about how Earth was actually formed and that stuff. Oops, sorry. All right, so moons. All right, so not only do we have planets and asteroids in our solar system, but we also have moons. There's a difference between a planet and a moon. A moon is also known as a natural satellite that orbits something other than the sun. Okay, so it is a body that orbits something else. And although in the long run everything orbits the sun, the moon, any moon, is orbiting a different body. And there are even really small moons that orbit asteroids. We do consider them moons. So, for example, our moon is orbiting Earth, and it actually orbits Earth, one time every 32 days. It is tidally locked to Earth, and so it takes a month for the moon to actually orbit the planet Earth. Okay, so like in an actual rotational way. In our solar system, there are more than 200 moons that we actually know about. And that's the key word, know about, because the moons have to be big enough to see in a telescope or a satellite. And, there probably are lots more out there, but there are many of them. Okay. Most of the moons do orbit the gas giants planets, such as Jupiter and Saturn. Jupiter leading the moon count, but even the smallest planets, like Pluto, has 5 moons around it. So remember that Pluto is not really considered a planet anymore, and we'll talk more about why later. But it's not. No. Our moon is actually quite large compared to all the other moons in the solar system in comparison to our size. Moon is quite a big body to be orbiting Earth. And so scientists believe that our moon was once a protoplanet. It was a Mars-like planet. And during that early solar system, the early solar system, Mars and Earth collided together. There is actually a lot of evidence for this. not only in the composition and the formation, but the fact that the moon is orbiting us and not a planet itself, which is kind of weird. But the moon is quite big, about 1/6 the size of Earth. That's a pretty big ratio. Okay. And so scientists believe that the moon ran into Earth in the early formation of Earth and the moon itself. And they call that the collision ejection theory. So essentially what ended up happening is that the Earth and the moon collided in their paths. Okay. And you got to remember back then there was lots of stuff. And then now there's not as much stuff because it's all been brought together. And so essentially the Earth and the moon were brought together and they were really big. So they didn't like that. So when they hit, they kind of spun around and became one weird large mass for a while. But then in that spinning process, Earth spit out what was left of the moon, and that object ended up rotating or orbiting that early Earth, and that became our moon. Based on evidence that astronauts have collected, that the moon is actually the same size and very similar composition to the planet Earth. So our moon is actually what could have been a planet, but it ran into us due to gravity or due to an orbit that was weird. All right, so temperature of the early solar system. Now this is important because this is where you get the idea of rocky body versus gas planet. So, okay, so. All right, so remember we have a bunch of gases in the clouds. Okay, this is not Saturn. This is a nebula in there. Okay, as the gases coalesced or came together to form a sun, that sun started releasing energy, nuclear energy, right? And then that started to increase the temperature of this solar system, and it increased the temperature a lot. So the area around the sun had very, very high temperatures. Very high temperatures, okay? Whereas the area outside of, further away from the sun is colder. We all know that. That's how our solar system works, okay? So the planets that are close to the sun are hot. Planets that are farther away from the sun are colder. And again, before this star was doing nuclear fusion, the whole entire cloud was pretty chilly. There wasn't a lot of energy there, okay? But as the star starts to form, okay, the only substances that can survive close to the star are going to be really dense materials like metals and those type of things. So the solid material are the only thing that could survive that temperature, being close to the sun. So the first 4 planets and moon that are in our solar system are rocky body planets because it's too hot to be a gas planet on there. Essentially, that energy from the sun just blew away all the gas and sent it to the outer parts of the atmosphere, okay? So again, that gas either went into the sun or they blew them out past the sun. So all the heavy, high temperature metals and solid material stayed close to the sun. That's the only thing that could survive basically that sun. So the inner planets are, again, in order to not vaporize, the inner planets are made of iron, silicon, magnesium, sulfur, aluminum, calcium, and nickel. Is really heavy metals. Okay. And then, of course, oxygen was attached to most of those metals because oxygen likes to rust and be part of the metal there. And then all the other smaller elements, the smaller particles, were sent out to the gas planets that are out here. Okay. Hopefully that makes a little bit of sense with why the first couple planets are the rocky body, and why the other ones are more massive. Okay, the rocky body stuff. The rocky body planets, again, are going to have those larger elements, and they're going to be, they're going to be things that can survive that high temperature. So if you got to think about things like Mercury, Mercury is it's a super small planet, but Mercury is tidally locked to Earth, meaning that the same side always faces Earth. Okay? And therefore, Mercury that one side, if it didn't have the high density, high temperature elements that don't melt, Mercury wouldn't be there. It would essentially vaporize, eventually just go away completely. Okay. However, Mercury is not the hottest planet in the solar system. I don't know if you guys know that or not, but Venus is actually the hottest planet in the solar system. The reason why Mercury is not the hottest is because it's tidally locked. Half of it gets sunlight, and half of it never gets sunlight, and I mean never. The other half of Mercury never gets sunlight. It never gets any energy from the sun. So the other half of Mercury is freezing cold. And so when you average out temperature, Mercury is actually not very warm. When you average out the hot side versus the cold side. Venus, on the other hand, Venus does rotate. It's not tidally locked. And so when Venus rotates, just like we rotate, all sides of Venus get the sunlight. Venus also has an atmosphere that holds the sunlight in and traps the sunlight. And then therefore, because it rotates and because it's really close, it's second planet, because it's really close to the sun, because it rotates, because it has an atmosphere, the average temperature of Venus is really, really, really high. Okay. All right. Yeah, that's what I thought. All right. So we'll take about another minute there just to kind of make sure we understand what's going on there. Then, of course, as you get further out past the rocky body planets, you get past the asteroid field, you start getting into your gas planet. And again, those gas planets can survive due to temperature. It can survive due, the coldness that's out there because they're smaller elements, smaller compounds out there. Okay. That's also one reason why they're so big when you get out that way. Okay, so all the material that was in the first area of the solar system, all that gases and dust and stuff went to the outer part, so they got vaporized by the early sun, and then it regathered out there and made Jupiter and Saturn and everything else. All right, so I'm turning that off. Okay, so other bodies in the solar system. We have comets that are also in our solar system, and comets are made from the early solar system. Okay, they are the leftover material. They're small, irregular shaped bodies in the solar system. They're composed mainly of ice and dust, and they're typically a few kilometers across. So they're not really all that big. Okay, but they are mainly composed of ice and dust. They travel around the sun in a very elliptical orbit, not a super round orbit, but a very elliptical orbit. And most comets will come close to the sun when they're coming towards it, but then they will get flown away from the sun out past Neptune, way out there. Okay, we have so they are on an orbit, so you can calculate when they will come back. Okay, and so we have some famous comets, not a lot right now, but we have a couple. Okay. So they can be classified as short-term or long period. It's a short period, a long period. The shorter period comets revolve around the sun in a short amount of time, obviously, and the long period one from there. Now, the reason why they have a tail on them, most comets, is because those comets are basically burning off the gases that are arriving, or that are the gases, the ice, the water that is inside of them, those on there. Okay. And so the water and the gases that are in there are being burned off as it comes closer to the sun, and that vaporizes and that creates a tail. Now, here's the thing about that tail, though. That tail is stuff. It is things that are coming off that comet. And so when a planet goes through, the leftover tail that's sitting out there in outer space, that stuff can be added to the planet. Okay. On that. So. All right, other bodies in the solar system. So asteroids are out there as well. These are sometimes called minor planets. Okay, they are rocky, so where you get the idea of minor planet. Because they're so small, there is no air or anything else like that on there, but they are made up of the same basic ingredients of our rocky planets. And again, they are from the early solar system out there. So, again, the early life of the solar system, the dust and rock were spinning together, okay, and the gravity brought all that stuff to make planets. but unfortunately, not all the ingredients were able to make a planet. So you guys probably know the asteroid belt that's in between Mars and Jupiter. Um, that could have become a planet, could have become a really big planet or multiple planets. But Jupiter's gravity is keeping Jupiter's gravity and the sun's gravity is stopping the asteroid belt from becoming a planet. Okay. And so if Jupiter wasn't there, there probably would be more planets out there that can come back together and form because of all those asteroids that are out there in between Mars and Jupiter. Luckily for us, it's not as dense as you seem. It's not like the movies where you can't travel through the asteroid belt. We can actually travel through the asteroid belt. That's a huge area. It's not that dense. It's not like there's a wall and you can't pass it. You can travel through it. We sent multiple satellites, multiple things out there. Then, of course, every now and then, those meteors do come to Earth, and they do land on Earth. This is my kid. We went out to a meteor crater in Arizona a couple of years ago, and this is one of the largest preserved craters on planet Earth, called Meteor Crater, and it's big. It's really, really big. I was surprised at how big it really was. And so this is the entire crater picture up here. In the middle, you kind of see where it actually hit here. And this crater that created, or this meteor that created that hole, was about the size of a school bus. So that's not a very big rock if you think about it. Not a very big rock that's coming down here and hitting our planet. Then of course you guys probably know the craters or the meteors, the asteroid comet. We don't really know what it was that killed the dinosaurs. There is a crater in the Gulf of Mexico, right off the border of Mexico, and we think that that's what hit Earth about 66 million years ago and killed off dinosaurs. All right, we only got a couple minutes left, so we're going to finish up here. So other bodies in the solar system, we have these things called meteoroids. Meteoroids, okay? They are objects in space that range from a small speck of dust all the way to small asteroids. Again, they're a little bit smaller than asteroids. Again, we think about like space rocks. So an asteroid is really big, like a minor planet, whereas meteors are really small, or meteoroids. When the meteoroids enter the Earth's atmosphere, or any other planet, at high speeds and they burn up, some people like to call them shooting stars. They're not shooting stars, they're meteors. They are called meteors. Okay, and again, they're burning as they go through the atmosphere due to friction of the air. When the meteors enter the atmosphere and they survive the trip and land on the ground, they're called meteorites. Okay, so meteorites are the rocks you can actually pick up and hold in your hand, and they're actually quite common. The good ones are pretty rare, but they're actually quite common, and you can actually find them really easily. Just using a metal detector out in the, normally people find them in the desert, places where grass doesn't grow and rocks are all over the place. Just use a metal detector and you can find some. All right, so we also know that we have rings around planets. Saturn is not the only planet with rings. Almost all of the bodies have rings on them. And then and scientists believe that all of the bodies used to have rings as well. But the rings is material, okay? And those materials will either fall into the planet, make the planet bigger, or a lot of the rings will turn into moons. Okay, they're moons that moved too close to the planet, and the planet's gravity ended up tearing apart the moon, and it created rings here. This is a real picture of Saturn. Yeah, this is a real picture. That's a pretty cool picture. Okay, it is a picture of Saturn made by the Voyager probe, so it's pretty neat, interesting one there. All right, so we do have a couple other things that are in our solar system. I think this is, yeah, I got last two little slides here. So if you go way out past, Neptune and area, we have a couple of other things that a lot of people don't really know about, and that is the Kuiper Belt and the Oort cloud. Out past Neptune, there's a Kuiper Belt where there's just a bunch of meteors and asteroids out there, just like the asteroid belt that we have between Mars and Jupiter. There's another larger one out past Neptune. Okay, and they call that the Kuiper Belt. So it's an asteroid belt, but way out there. Okay. Pluto is inside that Kuiper Belt. And that's one of the reasons why Pluto is no longer a planet, is because it's just a big asteroid. And so people call it a subplanet or a minor planet. Pluto is not the biggest thing out there in that Kuiper Belt. So if we were to call Pluto a planet, we would have to call a bunch of other things planets too, because they're just like Pluto, if not bigger. And so scientists, in order to avoid that problem, and because Pluto actually did not fit the definition of a planet, Pluto was, demoted to become a subplanet or a minor planet. You go even further than that, and way out here, there's also what's called an Oort cloud. An Oort cloud is basically an area that is surrounded by ice particles, icy objects, and again, there's no energy out there, very little energy out there. Okay, it's made up of billions of comets and billions of ice particles that are out there. Okay. All right. I'm trying to do something. All right. All right. And then let's see what else we got here. So the Kuiper Belt is way out here, past Neptune, Oort cloud, out there. So anyway, so most of this material out here are again made from the early solar system, and they're again gravity of the star. I mean, look how far away that star is. The gravity of the star is still holding all of this stuff together around this solar system. Okay. And again, just a final little wrap up here. Space is huge. Space is massive. Okay, so for example, here's the distance between Earth and the Moon. You can fit all the planets in between Earth and the Moon. Like literally, you can put all the planets in there. This distance, to space, the idea of space is just massive. It's so massive that light doesn't, light is actually moved kind of slow across the distance of space. And light, the fastest thing that we have, fastest thing that we know of, okay? And so we use a different term for distance when we're talking about space, and that term light year, or this other term that we had over here is called an AU, okay? And that is a rough estimated distance between the Earth and the Sun. It's a distance. We call it an atomic, or so, sorry, I gotta take a drink. All right. So I just want to kind of wrap up the formation of the early universe. There's lots of stuff out there. The solar system. So, and again, in our place in the solar system, we are not the center of the. We're not the center of the solar system. First off, we're not even the center of our galaxy. Earth. I don't know if you can see this little red sentence here, but our solar system is way out here on the edge of the Milky Way galaxy. Okay. Then our Milky Way galaxy is not even in the center of our galactic group. There's a whole bunch of clusters of areas, and again, the observable universe, we're just a small little tiny speck of that tiny entire universe that we have. Okay. So again, space is massive. The distance that light has traveled pretty far before it even gets to us. All right, just some other kind of weird stuff that's out there that a lot of people don't know about. Again, the Kuiper Belt out past Neptune. We have the Oort cloud that's even further out than that. And the Oort cloud is kind of where all the comets come from, and the comets are just going around and around and around and around the sun, going back and forth. Then, of course, if you have all these stuff that's orbiting the sun, sometimes they can hit, sometimes they can collide and go off path. And then you end up with an asteroid or a meteor that's flying through the solar system because it collided and bounced and went a different direction, a weird direction, and it might actually end up hitting other bodies, other planets, other stuff. Our moon is heavily cratered. If you actually go outside and look at the moon, you'll see the crater with your naked eyes. And the reason why our moon has a lot of craters is because it does not have an atmosphere. And so when the asteroid, meteors, whatever, gets close to the moon, it just goes right on in and it lands and it hits the ground. Okay. Earth has an atmosphere, so most of the stuff goes into Earth and it burns up when it hits the atmosphere, which is a good thing. Okay. Also, Earth has, because it had an atmosphere, a lot of the craters that were in the history of Earth are covered up by dirt and dust and wind and water and all that good stuff. All right, you guys have a handout that you guys are taking notes on, and you're just going to submit that and turn it in. So pretty easy for today. Okay. All right, I will see you guys later, and you guys have a great day. You guys have any questions, let me know. We're going to talk about Earth formation, Earth's history on Friday. See you guys later. I agree, Hannah. Earth will always be a planet to me too. Or Pluto. Pluto will always be a planet to me. See you later.